A quick one for today, guys. In today's class, we want to take a look at balancing of redox reaction. For those of you that are just coming across this video, if you check on my video catalog, I've dropped a full video on oxidation and reduction, which I explain the concept of reducing agents and oxidizing agents. And if you have to take a look at oxidation and reduction, we need to take a look at the four definition of oxidation and reduction, which is the addition of oxygen, removal of hydrogen, addition of electronegative elements, or removal of electropositive elements, while the last one is transfer of electron. And again, what is redox reaction? It involves the transfer of what? Electron. That is why we have what we call oxidation oil and rig. So oxidation is loss of electron, while reduction is gain of electron. That is not where we are going to today, because I've dropped a video on that aspect. So guys, let's take a look at the rules of balancing of redox equation or reaction. So guys, break down the equation into half equation and are balanced separately. So I'm going to show you guys how we are going to have our half equation. And the last one is combine the two equations in such a way that the overall equation does not show any change in a number of electrons. So guys, come closer. Let's take a look at how we can easily obey these rules with what we have on the board. But note one thing, that anytime we are taking a look at this redox reaction, we have the acidic medium balancing. We also have the basic medium balancing. So the one we have on the board is acidic medium balancing, because this particular video is for those students who are willing to sit for the next coming WAEC examination as well as JAMB examination. Exactly. So guys, come closer. Looking at what we have on the board, the first thing you need to do is that you should be able to identify what we have at the reactant side as well as what you have at the product side. Are you with me now? So guys, we do that. So for this, I have this. I also have this. Are you with me now? So guys, let's take a look at the first rules. Break down the equation into half equation and are balanced separately. Now, we are going to that first rule. So we have Fe2 positive and Fe3 positive. So guys, looking at what you have on the board here, from +2 to +3, there's an increase. At the reactant side, we have +2. At the product side, we have +3. So this is oxidation. So guys, the next one is we have MnO4 and we have Mn2+. Now looking at this equation now, guys, we are having 2 positive here, but what is the oxidation number of manganese here? Come closer. So we said we have Mn negative. Don't forget the rules of balancing of equation or when it comes to oxidation. So guys, this overall equation is equal to -1. What is the valence charge of oxygen? The valence charge of oxygen is -2. So you can say Mn plus -2. The substitute is what? 4. Multiply by 4. You close the bracket, is equal to what? -1. So guys, we can say Mn plus times minus give us what? Minus. 2 times 4, we have 8, is equal to what? -1. So guys, Mn is equal to -1 plus 8, we have +7. So our Mn is +7 here. So guys, from +7 to +2, there is what? A decrease compared to from +2 to +3. So if this is oxidation, which is a half equation, here will be what? Reduction. So now, guys, we are going to solve each of these separately. So I will choose this to be my equation 1 and this to be my what? Equation 2. So with that now, I can say that I have 2 plus, and here I have Fe 3 plus. So with this 2 minus 3, there is an invisible negative sign here. So 2 minus 3 will give us what? Minus 1. I said minus E electron. So in some cases, we can decide to put this one here but in chemistry, you don't have to, or in mathematics, you don't have to show this. There's what? Invisible one here. So guys, if this one minus is coming to this place to balance it, that this negative sign here coming to the product side will change to what? Positive sign. So with that, I can say we have Fe 2 plus, Fe 3 plus what? E. We'll take this one to be equation 3. Are you with me now? So guys, for this, we have Mn this, and we have Mn 2 plus. So guys, for the fact that we are having a positive 7 here and a positive 2 there, don't forget we have invisible negative sign here. And for this, we are balancing this in acidic medium. Take note of that. So guys, we are having 4 oxygen here. For you to have 4 oxygen at the reactant side, and when you come to this product side, we don't have anything like oxygen. By doing that, we are going to introduce water. And what is the quantity or the amount of water we are going to introduce at the product side? The number of oxygen you have here will tell us the number of water you are going to add here. With that, we said plus 4H2O. We are adding what? 4H2O here because of the oxygen here. With that, for us to balance both equations, are you with me now? 4 times 2 give us what? 8 plus 8 hydrogen ion. So guys, our positive 7 and our positive 2 for manganese respectively of the reactant side and the product side, that will give us 7 minus 2, we have 5. So we can say 5e electron. We call this equation 4. Now, we have both equation 1, 2, 3. So guys, we have obeyed the first rules that said break down the equation into half equation. This is a half equation and are balanced separately. We have balanced it separately. So guys, the next thing to do is that we are going to multiply the charge of each equation. For example, now I'm going to multiply, for instance, I'm going to multiply the charge of this all through with this, and the charge of this all through with what? Equation 3. That is, multiply the charge of equation 3 by 4 and the charge of equation 4 by 3. By doing that, he said Fe 2 plus times 5. This is the charge of equation 4. We have this Fe 3 plus E. So for the charge of equation 4 by 3, said multiply by 1. So we have MnO4 plus 8 hydrogen ion plus 5e electron. We have Mn2 plus 4H2O. So guys, with this now, the moment you multiply the charge of equation 3 by 4, this is going to change all through. And the moment you multiply the charge of equation 4 by 3, let's see what we are going to have, guys. So with this, I can say 5Fe2 plus 5Fe3 plus 5e electron. So we call this equation 5. Are you with me? So with this now, MnO4 plus 8 hydrogen ion with the 1 plus 5e electron. We have Mn2 plus 4H2O. Equation 6. Now guys, we are going to combine. So combine both equation. So how do we combine the equation? You combine the reactant side together as well as the product side together. So come closer. So we can say we have MnO4 plus hydrogen ion plus 5 iron 2 plus plus 5 E this. So we have the manganese 2 plus 4 H2O plus 5 iron 3 plus 5 E electron. So shows that the reactant side of both equation is showing what together. So guys, for you to deduce, the next thing to do is that when you check both the reactant side and the product side, you will deduce that we can only cancel this and this. And with that, we have Mn negative plus 8 hydrogen ion plus 5 Fe2 plus. We have Mn 2 plus 4 H2O plus 5 ion 3 positive. So guys, we have balanced this equation in acidic medium. So guys, let's check if this equation is balanced ionically. I repeat, let's check if this equation is balanced ionically by doing so check. This one is minus 1 plus 8, the 7 plus 5 times 2, we have what? 10. This 17. We have plus 2 here is 0. 5 times 3, we have what? 15. So we also have what? Plus 17 here. We also have what? Plus 17. This is acidic medium. And this is as well balanced ionically. So guys, let's take a look at the second method, which is how to balance a redox reaction in basic medium. But before we move to that, let's take the second rules. Combine the two equations which we have done here, the reactant side and the product side, in such a way that the overall equation does not show any change in the number of electrons, which we have shown that both the reactant side and the product side are balanced ionically. So guys, let's take a look at the next one, which is the basic medium.